Hello, Assalamu alaikum. This is the explanation of the electricity building ledger project. So, first of all, this is the core UML diagram. So, let's see. So, we have two sides. We have the PC side, which runs the main CPP program, the program which controls the CSV, the editing, the deletion, and the printing of the CSV. And we have the ESP32 side, which is responsible for the authentication side. So initially we boot the connection, we initialize the CSV. We always initialize the CSV. The application is launched by the user. So we open the COM port, which will be COM5 or COM9 according to our PCs. So we use the baud rate 115200 bits per second, and we wait for 2 seconds for the ESP to boot. So first handshake loop will run, and we will send an R, a request key. If the ESP32 receive it, it will set its state to authenticating state and will flash a blue light for once. Then it will send the key which was stored in the ESP32. If the key matches with the with the with the key which is on the ESP, which will be the same as this. This is missing an I here. And if that matches, our main CPPP program will send a S character, which will be the success signal, and the LED will flash 3 times. The green LED will flash 3 times on the ESP, and the authenticating stage will change to idle stage. So the ESP will be on the idle stage. It's not doing anything, but it is still on. There will be a 1 second delay, and if if the CPP program sends a fail F signal, then the LED will flash 3 times, and the COM port will exit, and the program will be terminated. Otherwise, if it is hmm, the CPP program will let the user use the main CPP and make the CSV or edit it or delete entries in it. So at the starting, we have some libraries to use. So we are using the include IO stream, which is for the cout, cin functions and getLine functions. The next library we are using is the standard library.h for the exit and the system for the pausing of the execution. We have fstream. This is the library which we are using to manipulate the file, for creation of the file, for reading the file, for writing in the file, for appending the file. So we are using OStream, which is the output stream. This is used to write in the file. And this is IFstream, input stream, which is used for reading the file. So these both creates an object, the output file of stream object and the input file stream object, which we will use to manipulate the file or read the file. Then we have SStream. SStream is used for easy string stream are used for easy string manipulations. So we will use this to parse our lines of code so we can collect the data easily, so we can distribute the line into separate rows or separate columns by the way. We have string in case the compiler does not support the string initially. We have IO manip for input output manipulation, set width for the column width if you are displaying the whole CSV, and left for left align. We are using Windows.h. This is important. This is used for Windows 32 API. This is the main library used for the COM port authentication. This is this library is handling all the authentication process with the ESP32. It will let us access the hardware of our laptop. Okay, function declaration. We have function. First function we are using is the initialize database function. This is used to initialize the database. If it is found, we will open it, check it if it's editable. If it's not found, we create a database. We have a bool is unique. Checks if the consumer ID is unique or not. We have consumer IDs in our CSV, and on the basis of consumer ID, we make the data. We cannot have the same consumer ID for like multiple data. Append record, it is used for add the new comma separated record to the end of the CSV file. It is used for appending a new record or adding a new record at the end of the file. Search by ID, this is used for searching any entry by the ID. Update record, we can update any record by the ID. We use the ID to find the record, then we can update it, we can modify it, edit it, or delete it completely. We have bool parse. So convert a single comma separated line CSV file from CSV file into distinct usable file. And convert the single comma separated file line from the CSV file into distinct usable string variables. So this is the main function that parse a line from the CSV into separate variables. So if we have 3 rows or 3 columns, so it will make 3 variables for each column entry in that row. So the next function is void display CSV. This is used to display the entire database of the file line by line and print the record. So, and this is another main function, the bool authenticate, the boolean return function that authenticate the hardware key. This is used to connect the physical microcontroller. This function will control the connection to the microcontroller and also checking the key. So first of all, our code always start from the main function. Initially, we have a string fname electricity bill ledger.csv. This is the name of our file. We stored it in a string named fname, and this is a global variable, so we can use this anywhere. And we created also three. We also created 3 variable red, green, and reset for color text in the terminal for better visual. So the red is used for error, the green is used for success, and reset is used for making the color back to white or black. So our first thing is we print verifying hardware security key on COM port. So this is the first thing that will be printed. Then we make a ID string for the variable for storing the ID, and the first thing that runs is the initialize database function. This is always the first thing that will run in our code. So we call the initialize database function to create the CSV file or check if the CSV file is already present or editable. So we are in the initialize database function. So it's a void returning function, so it returns nothing. We create a if stream fin name. We create an input file stream object named fin, which attempts to open the database file in read mode and check its existence. If fin is open, if fin was able to open, we just return because the database is already initialized. We don't need to do anything. We return to the main function. But if the offstream function does not return, we skip to the line and we go to the next line, which is offstream, fout name. So we create a fout class object of the offstream. So we create an object output object stream object named fout, which automatically generate a brand new blank file. So we create a brand new blank file, which is named fname, which is we have already seen its electricity billing ledger.csv. Then we fout consumer ID unit name. This is the header. So we use fout the angle brackets, 2 times the angle bracket, to write in the file. And we have written in the file the electricity bill ledger, consumer ID name and unit, which is the comma separated. This is the comma separated header in our file. And there's a basic rules in file manipulation. If you open a file and you have manipulated it and you are done with it, always close the file. So we close the file at the end. Now we have completely checked the initialize database function. There's nothing else in it. We go back to the main function. So after that, we go into the main function and we run a while loop, which is an infinite while loop. This is true infinitely. We will break this rule, break this loop to get out of this loop. Otherwise, this loop will run infinitely until the user exits the code or use the menu to exit the code. So the first thing we are running is if not equal to or not authenticate hardware key. So we already know that the authenticate hardware key is a boolean function. It returns a boolean and not. If the authenticate hardware key returns true, call the function authenticate hardware key, which returns a boolean value, and feed the condition its opposite. So we see So we can see we call the function authentication hardware key, and what it returns, we use its opposite to run this condition. So if it's true, I'm talking about the whole condition. If authenticate hardware key returns false, which turns this condition true, so we will output a denial text in red color, and we will say the access is denied because the ESP denied our access. The key didn't match, or we ran into a timeout error, and break the loop and exit the program. We are not going to do anything. We are not letting the user use this program. But if it is false, we run the code further and move to the next. So the thing is, now we have to see what's happening in the authenticate hardware key. So this is a quite complex piece of code. So we know we have a function that returns a boolean. So the first thing is doing, we are creating a handle. Okay, we are using the Windows API to create a handle hserial, which is named hserial, a handle class object hserial, which is equal to create file a function which takes multiple arguments. So the first argument is the thing we are accessing, the file we are reading, or the hardware we are reading. So the thing is, Windows deal devices which are connected to the communication ports or the USB ports as files. So we can read to them or we can write to them. So we use double backslash. So as we cannot print a backslash, we use escape characters to print double backslash dot and another slash and the COM port we are writing to. So right here I'm writing to COM port 9 or any other COM port which you are using. We are not writing, we are reading from it. So no, we see what we are doing. So we are reading into the COM port. Then the next argument we are passing is the access mode. In what mode we are accessing the file. So we are reading the device as a file. We are in generic read and generic write mode. We are both reading from the device and writing to the file. So we are both reading from the file, which is mostly happening, and we can also write to the device. And we are going to write to the device. The next thing is the sharing mode. Are we going to share this file or this port or this device to any other program or any other thing or any other process that's running? No, we are not going to do that. This program is only going to run for this program. This file is only available for this program, so we write 0 in it and it's not available for any other program. Security descriptor, it's null. We are not going to make this process, or we are not making this handle, the hserial handle or the file or the access, anything available to any child process. This is only available to this process. The creation action, open existing, so we are opening existing, ensures it only connect if the device is already plugged in. Open existing file, we are only opening existing file. If the file is not, if the device is not connected, we cannot access the COM port, so this hserial handle will not be created. The template file handle, we are setting the template file handle to none, so we are not copying any attribute from a template, and in reading file we also keep it always to null because we are not creating any template, or we are not, or we don't want to any template to be copied to the device. So here we have a condition which checks if the creative files throw an error like it fails or it succeeds. If it fails, we are going to throw an error that the hardware is not detected and return false, and we are going to end this function and exit the program so the user cannot use the program. If that does not happen, it returns a true, it returns a false, it returns a false. HCL is not equal to invalid handle value, it's a valid handle value. We are going to move on to the next lines. So we have some DCB, which are device control blocks. We are going to create a device control block structure, which is initialized to 0, and it's going to hold some settings for the serial port, which is one of which is the DCB length. So we are going to set the DCB length equal to the size of the DCB serial palms. Okay, parameters, the DCB serial parameters, which are in the next line. We are also going to insert the or add the basic communication state configurations, the default configurations into the DCB block in case we have a conflict. So we are also adding the default configuration to the edited configurations or our own configurations. Okay, these are the edited or our configurations. The number one are these are explicitly added configurations to match the connection protocol to the CPU and the ESP32. So these are the COM port or the Windows 32 API configurations we are doing for the communication. So the first one is the baud rate is set to 115200 bits per second. The byte size is 8-bit long. We are transmitting a packet of 8-bit long. And the bit stop is set to one stop bit. So we stop after 1 bit and no error checking parity bit. So we are checking no errors. We have no parity bits in it. And lastly, we apply the defined configuration to the setting block and to the actual serial hardware link. The next thing we do is we initialize communication timeout structure to handle the delay constraints. So we are now adding some delay to the code so we can successfully wait for the ESP to return the keys or the response. So we have to wait for the ESP for some responses. So we have communication timeout for the pauses for the ESP to respond to. So first timeout is the read interval timeout. We set the read interval timeout to 50, which is 50 milliseconds. We read time total timeout constant is 1 second. The maximum time to wait is 1 second, and the multiplier is set to 10. So we make this sure that the software is not expecting any response like immediately. We are going to add a little pauses for the ESP to respond. Otherwise, the software will crash or hangs or ends up in loops or don't even wait for the ESP to respond and give a timeout error and don't let any user to use the program. We are going to apply the timeout configurations. Then this is the first line that will be printed in our program. Waiting for the ESP to boot. We are messaging the window terminal to wait for 2 seconds. Sleep 2000 mean 2000 milliseconds. We are waiting for 2 seconds and making sure that the ESP waits for the Windows wait for the ESP to boot completely. Then we start writing. We transmit a character R over the serial line to signal the microcontroller and wait for it to send the serial key, which is the key we require. We need to match the key and send the response to the microcontroller to show a visual that we have successfully or we have failed the authentication process. After that, we are going to wait 100 milliseconds and we are going to create a buffer. So we are going to make a clean character array buffer of the size 9 initialized to null. We have nothing written in it. All are set to 0 or nothing written in it. And expected 8 character token. So we are expecting 8 character tokens and ending a null token which tells the buffer that the buffer is ended. The buffer is ended. And we reads and we read the number of bytes retrieved from the buffer or retrieved to the buffer. Next, we are going to try to read 8 bytes from the hardware device into our buffer. So we are reading the H serial. The H serial is the file we are reading from the COM port, the ESP, to the buffer. We are trying to read 8 bytes or the 8 characters, and into the byte read, we are writing into the add byte read how many bytes we have written. So we are going to convert the raw characters into a string that can be easily manipulated or used by the Windows Windows side program. And if the buffer received the received key is equal to the this key, which is Moji at here, we are going to send the receive success message S, and the ESP will trigger the green light 3 times. It will going to flash the green light 3 times on the RGB light. We are using the S3 version, so we have an RGB light on the development board. We are going to pause for 700 milliseconds, and then we are going to close the serial connection, and we are going to reset the green, and we are going to throw another message in a green color, access granted, to the console or the terminal. But if we did not receive the code key, or we receive the key which is wrong, we are going to send an F key, F character to the ESP. We are going to run the red key, and we are going to print a red error, invalid key provided, in the console of the console or the terminal on the PC side. And this is the last thing that will run on the authenticate hardware key function. This will run only if we were unable to read from the file. So this means we have either run into a runtime error, or we were unable to read from the file. So we are going to just close the file, and we are going to return false, and we are not letting the user to read or write to the file. Okay, now we are on the firmware. What's happening on the ESP in response to the authentication function. So first of all, we are going to import the basic Arduino H library, and we also include the fast LED.h for the LED which is on the development board, the RGB which is on the pin 48, and we are going to also use the number LED 1 and 48. So we have the CRGB LED set to the num LEDs, and we are also using the secret key set to the Moji. So we also set the it's a character array Moji here, which is the secret key array. We are also going to create an enum structure which have two states, either idle or authentication. Idle means the PC is waiting for the ESP is waiting for a request from the PC side. And authentication means we are waiting for the PC to verify the key. So either we are in a request mode, or either we are on a response mode. We are waiting for a request, or we are waiting for a response. And we initially set the state to idle. Then we, as always, in microcontroller which are based on the Arduino library or Arduino structure, have a word setup and void loop. So our word setup is we are using the serial baud rate at 115200. Okay, we are setting the fast LED link to the LED pin we have already initialized as globally. We set the brightness to a safe level. We are not setting it very high in case we burn the LED or anything else. We initially clear the lights, so we have no light showing on the firmware initially. Here we have the while loop. So this loop is continuously monitoring the serial port for incoming data. If we receive R, we are going to switch to authentication, and we are going to flash the blue light on the RGB light for once. Then we are going to check if the response is S or F. If the response is F and the state was authenticating, so we are going to send the key back. We are going to send the key back that we have validated the key, and we are going to flash the green light 3 times, and we are going to set the state back to idle from authenticating. But if we receive an F and we were in authenticating state, we are going to run the red RGB 3 times, and we are going to set the state idle. Now we are back to the main function. So in the main function, now we are printing a menu. So we are waiting for the user interaction now. We have access to the main function now. We are considering we have access to the main function. The authentication was successful. The initialize database function was successful. So the first thing we are doing are printing a menu header. So we have electricity bill ledger as a header. If the first thing is, do you want to write or add entry? Do you want to search by consumer ID? Do you want to search by username? Do you want to display the whole CVS or do you want to exit? One will write add, two will search by ID, three will update, four will display, and five will exit. So if the choice is one, so we are going to create a variable which will take the choice. If the choice is not any of the usable choice or it's like an any escape character, we are just going to continue. We are going to completely ignore that and we are going to next line. If the choice is one, we are going to run the function append record. So now we are in the append record function. So in the append record function, we are going to create three new variables, the ID, the name, the unit, which are our data for a line. So we are going to ask the user for the lines. We are going to take the data and now we are going to another function which is unique ID. We are only going to write a data if its ID is unique. If the ID is not unique, we are not going to write into the CSV. We are going to throw an error. So let's say if the ID was unique, so we are going to open the file in output function and we are going to open it in append function. So we are at so our the pilcrow or the writing cursor is at the of the file. So if the file was unable to open, we are going to throw an error and return the function and close and return to the menu again. But if the file was able to open, we are just going to write into the file the name, the ID, comma, the name, comma, the unit. Then we are going to, let's say we have the input 1, 2, 3, 4, and the name was meow and the unit was 267. So we are going to write in the file 1, 2, 3, 4, comma, meow, comma, 267. Then we are going to close the file. The file is closed, and then we are going. Then this is the whole append function. Now in the whole append function, we have is unique function. Is unique function is a function that will check if the ID sent to the append function or the ID inputted by the user is it unique or not. If it is unique, we are going to write to the function. If it is not unique, we are not going to write to the function. So the first thing we are going, it is a boolean function which returns a boolean return data type. So the first thing is we are going to open the file in reading mode, and if we were able to open, we are going to move on. If we were unable to open, we are going to throw an error. Then we are going to create another then we are going to create another variable which is a string to take a line. So this is the line that we are taking from or reading from the CSV. So we are in a reading mode as the is unique function is whole a reading mode function. So we are going to say if we were unable to read the file, we were unable to receive a file initially. So the initial line is the header. If we don't find the header, we are going to throw an error. So checking the first line, if we did not find any header, we are going to throw an error. But if we were unable to, we were able to find a line, like the header was found, we are going to skip the header and we are going to move to the next line and we are going to move to the next line of the code. We are going to create three variables, the consumer ID, the name, the user ID, unit. And what's happening here is these three variables, we are going to get line, we are going to get the line from the user. We are going, this is a while loop, get line in from the fin is the file in character, the input character, the reading line, and we are taking line from it, one by one line from it, and we are going to read line by line it till we reach to the end of the file character. Okay, if a line is empty, We are going to skip it. We are not going to end the program or anything. There can be an empty line in it. We will read till we reach the end of file character. So an empty line is not an end of file character. Then we run into another function. We are going to call the function, and if it's returned nothing, if it returns nothing, we are going to continue. And we are calling the function by the argument the line. We are passing to it the consumer ID, the name, and the unit. So that pass function, what it does, we are going to send it the line we are reading, and it will send us back the consumer ID, the name, and the unit. So the pass function just separate the line into the consumer ID, name, and unit. If the consumer ID match the ID is not unique. We don't need the ID. So let's see, we have 1234, and we have also 1234 in the database. So the ID is not unique. We are going to return false, and we are going to throw an error in the terminal, and we are not letting the user to edit the or we are not using we are not letting the user to append or edit or delete append we are not using we are not letting the user to append into the file. But if the data was different, let's say we have 2456, this is a unique ID, so we will let the user to write. Then as always, we are going to close the file, and we are going to return true as we were able to read the file. The ID was unique. Then we have to discuss the parse function as we have discussed it, as we mentioned the parse function in the is unique function. So the parse function takes the string line, then it takes the ID, the name, and the unit by reference. So we are taking the original values and the original addresses, and we are going to edit the IDs, names, and string which were passed to us by the function. So most of the string ID, the name, and the unit will be function defined. They are not going to be global. So we also create three variable ABC. We create a string stream for the line for easy manipulation. We get the line. Okay, so here we are going to take line. Slicing the slipstream at the delimiter. So the delimiter we are checking is the comma and storing it in the variable A, B, and C. So here we have the line. So first we read the string stream, which is 1234 meow 267. So we read it till the 1234 and the comma, and we're going to output a equal to 1234. Then we read the meow, b equal to meow. Then we will c, and c equal to 267. Then the ID ABC are updated to ABC, and the return is true that we were able to pass the data, and the ID, the name, and the unit which are called by reference are already updated. So now we are back into the main function, and we are going to discuss the whole menu and not going to run into the main function again and again. So if the user makes the choice 2, we are going to take some inputs, and we are going to run the search by ID by passing the argument ID, which is a string. If the choice was 3, we are just going to call the update record function. If the choice was 4, we are just going to display the whole CVS. And if the choice was 5, which was exit the function, exit the program, we are just going to break the loop. And if the while loop is break, we run into a system pause and return 0, and our function is completely, the main function returns, and our program exits. Here we have another function which is search by ID string ID function. Here we have another function search by ID which take a parameter string ID by value, and it also returns a string. So we create a reading file object again. If the file was unable to open, we are going to throw an error. We are going to create another 4 variables, the line, the consumer ID, the name, the unit. And if we're unable to read the header, we are also going to throw an error of header missing or the file is empty. So the same thing is happening here. We are going to take get lines from the file, till the end of file character. If the line is empty, we're going to continue. If parsing was enabled, we are going to continue. If we are unable to parse, we are going to continue. If consumer ID is equal to ID, we have a record found. This is the thing we have to do. So we were searching by ID. Let's say we have 1, 2, 3, 4. First, you run the first entry. No, does not match. The second entry, we have a match. So what we are going to do, we find the match. We are going to output it. We are going to return that line. And let's say we have an ID that does not match. So first entry doesn't match, second entry doesn't match, third entry doesn't match till the end of file character. If we don't find a file, we are just going to throw an error that record not found, and we are going to return an empty string. Then another function is update record function. The update record function does not return anything, so it uses a string ID. So first of all, we are going to take an ID that we want to update. Then we are going to check that if the string ID is valid by searching by the ID. If the ID was found, it is valid. If the ID was not found, it is invalid. If the valid was empty, we are going to return. We are going to throw the function. We are not going to do anything. We are going back to the menu. Then if it was not empty, we are going to ask the user, do he want to update or delete the entry? Then checking the option. If the option was wrong, we are going to return because he chose a wrong option. Then we are going to create a reading file, which is the original file. If the file is unable to open, we are going to throw an error. We are going to take header. This time we are going to make an header string, and we are going to take the header from the file. If the file was empty or there were no header, we were unable to take header. So we are going to throw an error. We are going to close the file, and we are going to return the function. This function is stopped. But if we are able to take the header, we are going to create a temporary file, temporary.csv, and we are going to open it in writing mode, the output mode. So we are going to create an object, output object stream for first object, and we are going to write the headers in it and line character. Then we are going to again create the 4 variable, the line, the consumer ID, the name, the unit which are required for the path function. We are going to take line till the end of the file character from the reading file. So we have 2 files, the reading file and the writing file. The reading file is the original file and the writing file is the temporary file. So we are going to check if the line is empty. We are going to continue. We are going to pass. If we were unable to pass, we are going to continue. If the consumer ID matches and the option was equal to 2, we are going to continue. But if the consumer ID matches and the option was 1, we are going to ask for the name because we were in the update mode now. We are in the edit mode. We are going to ask for the name you want to edit for that ID and the new unit you want for that ID, and then we are going to print it to the file. Else, we are just going to write lines one by one till the end of the file corrected. Then at the end, we are going to close both the files, and we are going to remove the original file and rename the temporary file to the original file. So let us again see this function, what's happening in this function, as this one was quite long. So initially we take an input, which is the ID. Let's say we take the input 1, 2, 3, 4. Then we take the choice. Do you want to update the file or do you want to delete the file? Then we open the original CSV and we read the header from it. We take the header from it and store it into the header variable. Then we create another temporary file and we open it in writing mode. So here we are going to write, and from the electricity bill ledger.csv we are going to read. Let's say, so we are also always going to write the header into the temporary CSV file. Let's say, okay, we read the ID, we check the ID, we didn't find the ID. Okay, we move on next. We didn't find the ID didn't match, we're just going to add the line. We have a matching ID. 1, 2, 3, 4 is in the input, the ID we wanted to check, and 1, 2, 3, 4 is also present in here. if the choice was 2 to delete. If you wanted to delete the ID, if you want to delete the entry, we're just going to skip and we are going to the next line and write that line. But if the choice was 1, we want to update the file, we are going to take some inputs. We are going to take the name, new name, let's say the name is Howl and the new unit is 169. Then we are going to write the updated record in the CSV, and then we are going to the next file, next line, and write it till the end of the file. Then we are going to close both the files and rename them. The another function is display CSV function. The display CSV function is used to display the whole CSV in a table format. So it returns nothing. We have the 4 variables which are required for the parsing. If we were unable, we are going to read the file. If we were unable to open the file, we are going to throw an error. We are going to take lines till the end of the file character. If the line was empty, we are going to continue. If we were unable to parse, we were going to throw an error. And we are going to parse the lines one by one. Every entry will be left aligned. The consumer ID will have 20 character spaces, the name will have 40 character spaces, and the unit will have 10 character spaces. Then we are going to close the reading file object and end. So let's take a look how this code is running. So initially I don't have the ESP connected. So verifying hardware security key on the COM9 or COM5 or whatever. Hardware key not detected. We were unable to detect the hardware key. So press any key to continue. So we were unable to access the file. So let me just connect the ESP and we are going to run the program again. So on the ESP, we are waiting for the boot. We have a blue light on the ESP. We have the 3 green light. We have the access granted as the key matched. So let us do something to make the ESP. Let us do. So let us change the key in the code and check what will happen to the ESP. So here we go. I'm going to. So the key is. So here is the function, and the key is. Where is the key? Where is the key? Here is the key. Let's just remove the A here, and then we are going to run the function. So the function is running. I have a blue light and 3 times red light, so I was unable to use the function, unable to use the program. So let's just edit it again. So let's just edit this again. So the ESP is connected and we have the menu. So we, so what I'm not going to do, I'm going to do another thing. As this loop always run on the while loop, the menu loop, I'm going to disconnect the ESP. The ESP is disconnected. It will let me run the program once. So let us say I'm going to write to the CSV. I'm going to write to the CSV. So it says enter consumer ID. Let's say I have 657890345611. Our consumer IDs are long, quite long. Name, let's say Arbaz. Unit, let's say 345. So we were unable. So we have written to the ledger, the CSV, but we also did not have the ESP connected, so it terminated the program. So I'm going to connect the ESP again, and this time we are going to run it like it should. So writing, you have seen how it writes. So let's search by a consumer ID. I don't know any consumer ID over here. We have to check the CSV. So let's say this Fatima one. We are going to take this copy. We are going to paste it. So let's see what happens. So we have the record found. So every time you go to the menu, the ESP will boot. So it will not let a user go for go to the menu again if the ESP is not connected. Let's update a record. Let's update the Fatima one. We are going to delete that record. So we just deleted the record. You can see over here the Fatima record just disappeared. Okay, and what we are going to do, we are going to add a record. We should add a record. The consumer ID was this. The name was Fatima, and the unit was 457. Let's say this. So we are waiting for the ESP to boot again, and we need to update our record. So we are going to update our record. Let's say we are going to update this Dishan one, and we are going to name him Ali. But no. We are going to chase update. We are going to name, and as it found, it will let us. And here you can see in the update one, we have a temporary CSV over here and the electricity bill ledger over here. And we are going to 1, 2, 3, 4. So as I press the return key, you can see over here these two will rename. This will be renamed to electricity bill ledger to CSV, and this will get deleted. Okay, and for the 4, if we press the display.csv, we get the whole CSV. And if I press exit, I exit the code. And here you can see the Fatma one added over here.